Okay, exercise 13E, we're going to do example 18. Example 18, if we read it there, is about an iron bar placed in a room which has a temperature of 20 degrees Celsius. The iron bar initially has a temperature of 80 degrees Celsius. It cools to 70 degrees in 5 minutes. Capital T be the temperature of the bar, little t is the time in minutes. Construct a differential equation, solve this differential equation, and then sketch and then find out how long till it cools to 40 degrees. So the important information we get out of here, room temp's 20, initial temp's 80, in 5 minutes it's 70. Now we've got Hooke's law of cooling. So our differential equation, dt negative k, because it is cooling, the temperature is decreasing, T take 20. Because remember, this 20 is our room temp, okay? So where the 20 is our room temp. We've got to solve this differential equation. So I'm going to go dt over T take 20 is negative k dt, matching our dt's with our correct variable. Integrate both sides. ln t take 20 equals negative kt plus c. Of course, that's going to be t take 20 is e to the negative kt plus c, or t equals ae to the negative kt plus 20, where a equals e to the c. So we've solved our differential equation and we've got it down into that form. Now obviously we get it to that form, we still have two constants we don't know. And this is where we can use our information given in our question. We know when T is 0, initial temp 80 degrees. So I'm going to have 80 equals AE to the 0 plus 20. So 60 is A. 60e to the negative kt plus 20. So I found one of my constants. That's always the easiest one for us to find. Then we also know that if T is 5, T is 70 degrees. So we substitute that in. 70 equals 60 e to the negative k5 or 5k, whichever way you want to go, plus 20. Let's solve that in. So I'm going to bring the 20 over. Then I'm going to divide by 60, so that gives me 5, 6 equals e to the negative 5k. Rearranging that, I'm going to get therefore negative 5k is going to be ln 5 on 6. Sorry, I'm just going to go to a different bit of paper. We're trying to work k out. So k is going to be negative 1/5 ln 5/6. And that's where we get our k. Is everybody happy with that? Now we put that in, we get t equals 60 e to the 1/5 ln 5 on 6 plus 20. Now, I know there was talk, because we said, well, what's happening with the negatives? But we know because this log is a log of a fraction, that actually will be negative. We can work out what that is. If we go into our calculator and we go 1/5 times ln in bracket 5/6, that's approximately, so we can write it over here. T is 60 e to the negative 0.0364643 plus 20. So note, even though it didn't look like it was negative, like we said in our original thing, k is negative because it's decreasing, it is negative. So we can graph that, of course. So let's graph it. Menu, go down to graph. Well, let me just delete what I had in there. So I'm going to put in 60 times e to the power of, I'm just going to put in 3. Oh, I should have left my t off, didn't I? Silly me. 3, 6, 4, 6, 4, 3x plus 20. Draw. Let's see, I think my view window is probably a bit out, so let's change my view window. Let's make that 100. Oops, sorry about that. Let me just go view window again. My window is too small. Now we can see the graph when I correct my view window. Oops. So I can sketch it out if I need to know what those points are. Y-intercept is 80. Okay, and so it's, and we go down. So we can sketch it with the cooling going down. Of course, it's not going to go below 20 because 20 is our room temp. So our last bit of a question here was, when will it be 40? So T equals 40, what does little t equal? Pop that in. T is 40, 60, negative E 0.36463T plus 20. Now, of course, option here is, of course, if you've got your graphic calculator, you could go solve n. If you didn't, that's going to be 20 equals 60 e to the negative 0.3, 64643t. Then, of course, you divide, so you get a third equals e to the negative 0.0364643t. So negative 0.0364643t equals ln a third. T equals negative 0.0364643 ln a third. And we should get an answer of about 30.1284. So therefore, oops, we're going to say temp is 40 degrees at approximately 30.1 minutes. Finishing that off. So option here, solving that last one out, solve it like that if you want, or just solve n would be correct. Okay.